Maxwell equations of electromagnetism and Hertz experiments on generation of detection of electromagnetic waves in 1887 strongly established the wave nature of light. Experimental investigations on conduction of electricity at the end of 19th century through gases at low pressure led to many historic events. Important discoveries are X-rays by Röntgen and electrons by J.J. Thomson. At a sufficiently low pressure, a discharge took place between the two electrodes on applying the electric field to the gas in the discharge tube. A fluorescent glow appeared on the glass opposite to cathode. The color of glow depends on the type of the glass being used, yellowish green for soda glass. This is an example. The reason for this yellowish glow is due to the rays coming from the cathode. These cathode rays are discovered in 1870 by William Crookes. It was suggested that these rays consisted of streams of fast moving negatively charged particles. J.J. Thomson confirmed this experiment. He applied mutually perpendicular electric and magnetic field. He determined the speed and specific charge, means charge to mass ratio E by m of these cathode rays. Speed of rays is found to 0.1 times or 0.2 times the speed of light. The E by m value of this one is found to be 1.76 into 10 raised to 11 coulomb per kilogram. This value is independent of the nature of material used and the gas introduced in the discharge tube. The same flow of charge or moving charges can be found by some metals irradiated by UV rays. The same is found when some metals are heated at high temperature. The same fast moving electrons in negatively charged particles are moved. This was named as electrons by J.J. Thomson in 1989.